Hello everyone. So in this particular video, we'll try to dig in some in-depth that is related to the collision of elastic bodies, right? So we have looked into the previous cases wherein we'll be having two velocities, basically u1, u2, which corresponds to the initial velocity, and similarly we also had u1 and u2 which corresponds to the final velocity. Basically, if you're talking about velocity, then obviously we have something that is referred as kinetic energy, which is half mv square. So a kinetic energy depends upon your mass as well as your velocity. So in both these cases you will be having kinetic energy. Okay, so your kinetic energy before your impact is equal to 1 by 2 m m1 u1 square plus half m2 u2 square. So this is your energy which is produced before your impact. Similarly, after your impact, after it is collided, you are going to have kinetic energy which is half m1 v1 square plus half m2 v2 square. So this is basically the energy that you get after your impact, right? So as I stated, if it is perfectly elastic, wherein your coefficient of restitution E is equal to 1, there is no energy loss. E1 is equal to E2. Whereas but in the real time scenario, your E will vary from 0 to 1. Okay, if that is the case, you're prone to have a energy loss, which is the difference between your final and your initial kinetic energy. So if you derive it, your loss in kinetic energy is equal to m1 m2 divided by 2 into m1 plus m2 into u1 minus u2 the whole square into 1 minus t square. So this formula, please do remember it. This is where you will be having your loss or your energy loss, which will be present because your restitution is not either 1 nor it is 0. Okay. So with this definition, we'll directly get into the problem. Hello everyone. So this is the problem we'll be looking into. So here we have a set of known values. So here it has been stated that we have a mass of 1 kilogram which is moving at a velocity of 3 meter per second. So basically they have given us mass m1 and u1 which is 3 meter per second. It overtakes another sphere of mass m2 in the same line, which means it is a direct collision and it is moving at a velocity of 6 meter per second. So they have given us the mass m1 1 kilogram, u1 which is 3 meter per second. Similarly, mass m2 which is 5 kilogram and u2 which is 6 meter per second. And they have asked us to find out what is the loss in kinetic energy, and they have also told that E is equal to 0.75. And here again, direction of motion of the first sphere is reverse. You have asked to prove it. So you have to find out what is the value of V1 in this particular case also. Fine. So first we'll find out EL, right? So your EL is equal to, remember the formula, M1 by M2 divided by M1 plus M2 into U1 minus U2 the whole square into 1 minus E square. So if you substitute the values, you will be able to find out the answer. So it is M1 is 1, M2 is 5 divided by 2 into 1 plus 5 into U1 is 3 and U2 is 6, 1 minus 0.75 square. So this is 5 divided by 2 into 6, 12 into, so here you have 3 minus 6, so it is minus 3 square, or it is 9, and if you just try to find out 1 minus 0.75 square, you will be ending up with a value of 0.4375, right? So let me write it over here. So now if you just simplify it, your final answer is going to be 1.64 joules. Please note down the unit, it is joules. So now we have found out what is the value of your loss in energy or loss in kinetic energy, right? Now the other parameter that is remaining is V1. So if you have to find out V1, obviously what we are going to do is your conservation of momentum. Okay, so your momentum equation, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So let me just fill out the values. 1 into 3 plus 5 into 6 is equal to 1 into V1 plus 5 into V2, right? So this is 3 plus 5 into 6 is 30, V1 plus 5 V2, or 33 is equal to V1 plus 5 V2. So V1 plus 5 V2 is equal to 33. I will consider this as equation 1. The second equation is V2 minus V1 is equal to coefficient of restitution E into U1 minus U2. V2 is unknown, so V2 minus V1. E value is given, which is 0.75, and if you try to recollect what is the value of U1, it is 3 and U2 is minus 6. So this particular terminology will have it as minus 2.25. So your V2 is equal to V1 minus 2.25. So substitute it in the equation 1. So V1 plus 5, instead of V2 we can write it as V1 minus 2.25 is equal to 33. So it is V1 plus 5V1 minus 5 into 2.25, which is 11.25 is equal to 33, or 6 V1 is equal to 33 plus 11.25, which is 44.25. Hence your V1 is equal to 7.375 meter per second. So now we have found out both the value of your loss in kinetic energy as well as the final velocity of the first body. If you want, you can substitute it the value of V1 over here, which will give you what is the value of V2. Even that we'll do, though it's not asked in the question, we'll do it. So V2 is equal to V1, which is 7.375 minus 2.25, or V2 takes a value as 5.125 meter per second, right? So with this particular problem, we'll put a full stop to the collision of elastic bodies, most importantly the collision of or direct collision of elastic bodies. Okay, so just look into the videos. If you have any doubts, please get back to me. Thank you.